welcome to EC Electronics. This is a video on preparation of ISRO Technical Assistant Electronic Post, and we are going to see the questions from the area Electronic Instrumentation and Measurement. This also includes the areas like error analysis and transducers. Okay, so let us see what is the first question. Okay, so this question is related to the error analysis of the instruments. The current flowing through a resistor of 1 ohm is measured to be 25 ampere. But it was discovered that the ammeter reading was low by 1% and the resistance was marked high by 0.5%. Find the true power as a percentage of original power. So when the current is being measured by an ammeter and then the ammeter have some faulty readings, there will be variation in the power calculation also, right? We know that the value of power P is equal to I squared into R, right? So we have been given the value of I and R, but it was discovered that the ammeter reading was also wrong and also the resistance was marked wrong. Now we need to find the true power as a percentage of original power. Now true power means the actual power which we have to get, but it was obtained wrong because of the variation in the ammeter and the resistance. Now the original power is the power which was actually calculated using this values obtained. So what will be the original power? Original power will be equal to I squared into R because it is directly given in the equation, in the question. So 25 square into R is 1. So it will be 625 watt, right? So the original power will be 625 watt. Now we need to calculate I'll write it here, the original power is 625 watt. Okay. Now we need to find the true power. For that we need to find the true value of current and true value of resistance. What is the true value of current? It is given that the ammeter reading was low by 1%. That is 1% more is for the current because the ammeter reading was low by 1%. So the true current will be equal to the current given 25 into 1 plus 1%, 1 by 100. Okay, so it is 0.01. 0.01. Right, so it will be 25 plus 0.25. Right, so it is a 25.25 is the true current value. Right, now I'll write it here. I is obtained as 25.25 ampere. That is actually the true value of current, but because of the faulty reading of the ammeter we got it as 25. Now what is the true value of resistance? True resistance will be actually little less because the resistance was marked high by 0.5%. So it will be the value R into 1 minus 0.5 by 100. Right. So the value of R is given as 1 ohm. So 1 into 1 minus 0.5 by 100. That is 1 into 1 minus 0.5 by 100 will be 0.995. So 1 into 0.995 is 0.995 ohms is the true value of your resistance. Now we have the true value of current and also the true value of resistance. So we can find the true power. Okay. So what is the equation for true power? True power is equal to I true square into R true. Okay. I'm going to substitute. Again 25.25 square into 0.995, right? I hope this concept is clear. See, when the current was measured, the ammeter was faulty. Due to that, the current is measured 1% low. So 1 plus 1% will be the true current. That is 25 plus 0.25 will be your true current. So the true current is 25.25. Also, the resistance value is marked wrong by 0.5%. So you have to increase that percentage to get the true value of your resistance. So we'll get the true value of current and we'll get the true value of resistance. Now we can find the true value of power, because actually we have calculated the power with the previous values which were wrong, right? Now we need to find this error percentage. Okay. Now if you calculate this, you will get the value as 634.37 watt. Now we have the true power, we have the original power. We can find the error ratio, right? So we have to find the percentage of true power as original power, means 634.37 by the original power is 625 into 100, right? This will be the ratio of powers. And what will be the value? It is obtained as 101.5%. So this is actually the variation in the power or the error ratio. It is the ratio of, it is not the error ratio, it is a variation of, or the ratio of the true power to the original power. Okay. So this is actually happening because of the error in your instruments. Okay. So the answer for this question is 101.5%. So the answer is obtained as 101.5%, right? So we are actually calculating the true power to the original power ratio. So this is actually happening because of the error in the instruments. Okay, so this is one type of question which you can face in your technical assistant examination, because the syllabus includes the electronic instrument and measurements. Okay, so let us see what is the next question. Wheatstone bridge consists of dash. A. 4 resistor arms. B. 2 resistor arms. C. 6 resistor arms. D. 8 resistor arms. Okay, so what is actually a Wheatstone bridge? Wheatstone bridge is used to calculate the value of an unknown resistor, connecting it to the arms of a Wheatstone bridge. Okay. I'll draw the figure roughly for a Wheatstone bridge. It will look like this. This is a 4-armed circuit. So the correct answer will be 4-arm. Anyway, I'll complete it. There is a galvanometer connected here. These are R1, R2, R3, and this is Rx, which is the unknown resistance, and it is connected to a voltage source. So this is a Wheatstone bridge. So the functionality or the use of a Wheatstone bridge is to find the value of an unknown resistance. So here this unknown resistance is connected to the 1 arms of a Wheatstone bridge, and which originally consists of 1, 2, 3, 4 resistor arms. Okay. So this is a basic thing about a Wheatstone bridge. So the correct answer for this question is option A, which is 4 resistor arms. Okay, next question. Piezoelectric transducer has dash. Option A, copper rod. B, aluminium wire. C, gold. D, quartz crystal. Again, the correct answer for this question is quartz crystal, because the piezoelectric transducer is having some piezoelectric material, and out of this option, the correct answer for a piezoelectric material is quartz crystal. Now, what is the piezoelectric transducer? This piezoelectric transducer is used to find the known electric quantities such as stress, strain, acceleration, vibration, etc. So these quantities are being measured using a piezoelectric transducer. That is, if these quantities are being applied, that is due to some stress, it will generate some voltage. That is the quality of a piezoelectric material. And also these piezoelectric materials can produce high voltage with low current. It is another feature of the piezoelectric transducer. It can come in questions also. So whenever you are thinking of this piezoelectric transducer, just keep in mind that it is used for measuring non-electric quantities such as stress, strain, acceleration, vibration, etc. And also it is having some piezoelectric material which will generate high voltage with low current. Okay, so the correct answer is option D, which is quartz crystal. The next question is, balance equation of a Kelvin bridge is dash. So Kelvin bridge is another type of bridge which is used for finding the unknown value of resistance. Its diagram is slightly changed from the Wheatstone bridge. It is like this. There are again 4 resistor arms like this. R1, R2, here also one resistance, R3, this is R2, R3 and Rx. Here again there is a galvanometer. This galvanometer is having a swiping arm. Okay, now connecting these two, there is a voltage source. Okay, so this is the rough diagram of a Kelvin bridge. Now they are asking what is the bridge balance equation for a Kelvin bridge. It is the option B is the correct answer. We'll draw it correctly. Okay. So Rx, which is this is the unknown resistance. R1, R2 and R3 are non-resistance values. So Rx is equal to R1, R2 by R3. This will be the balance equation, bridge balance equation for a Kelvin bridge. So this is the rough diagram of a Kelvin bridge. One arm of the galvanometer, or the galvanometer arm, is a swiping arm, and the rest of the diagram is almost same as that of the Wheatstone bridge. Okay, so the correct answer is option B, whereas Rx equal to R1 R2 or R2 R1 by R3 is the balance equation. Next question is, a resistor of 10 kilo ohm with tolerance of 5% is connected in series with 5 kilo ohm of 10% tolerance. What is the tolerance of the series network? So we need to find the value of the series network tolerance. Okay, I'll remove this in order to make some space. Okay. Now the options given are A 9%, C 8.67%, B 12.04% and D 6.67%. In this question, they are asking the tolerance of the series connection of two resistors. Okay, so there is a 10 kilo ohm resistor and a 5 kilo ohm resistor. The 10 kilo ohm resistor is having 5% of tolerance and 5 kilo ohm resistor is having 10% of tolerance. So even though it is marked 10 kilo ohm, including the tolerance, the value can vary up to little more amount. That is, for 10 kilo ohm, if you consider, this 10 kilo ohm is having 5% of tolerance, right? So 10 into 5 by 100, that is 0.5 kilo ohm. So 0.5 kilo ohm also can be added with this 10 kilo ohm since it is having a 5% of tolerance. So the actual value of resistance will be, or the tolerance value will be 10 plus 0.5 kilo ohm. That is 10 kilo ohm plus 0.5 kilo ohm. Okay. And also for the 5 kilo ohm resistance, this 5 kilo ohm into, what is the tolerance? It is 10%, right? So 5 into 10 by 100. Here again, it is a 0.5. So the actual value of this 5 kilo ohm resistance can be 5 kilo ohm plus 0.5 kilo ohm, right? Since we are adding this 0.5 kilo ohm and 0.5 kilo ohm obtained by including the tolerance values. Now, it is said that these 10K and 5K is connected in series. So, when the resistors are connected in series, what will happen? The total resistance will also increase, right? When two resistors are connected in series, the resultant is the sum of the values, right? So, due to that condition, what will be the total resistance of the connection? Let us see. Okay, so it is 10 kilo ohm plus 0.5 plus 5 plus 0.5, right? That is the total resistance, here I'll write it. Total resistance is equal to how much? There is a 10 kilo ohm original plus there is a 0.5 K of tolerance plus there is a 5 kilo ohm original plus there is a 0.5 K of tolerance. Okay, so while considering the tolerance, you have to keep this thing in mind that this tolerance can be either added or subtracted. That is, tolerance means up to this percentage, the value can vary, either increase or decrease. That is the meaning of a tolerance. That is, when you are saying 10 kilo ohm having a 0.5 K of tolerance means the actual value of the 10K can vary 10K plus or minus 0.5 K. So this is the meaning of the tolerance. It can be either an addition or it can be a subtraction. So since this is a series connection, we are adding the tolerance values also. Okay, so I hope this concept is clear. Tolerance means you have to add the tolerance value or subtract the tolerance value. That is 10 plus or minus. It can be either a plus or a minus. But since this is a series connection, we are adding the tolerance values also. Okay, so 10K plus 0.5 plus 5 plus 0.5 is equal to 16K, right? So the total resistance including the tolerance is 16 kilo ohms. Now, what was the actual or the original value of the resistance? So, original value is simply by adding 10K plus 5K. We are not considering the tolerance. Okay, so it is 10K plus 5K is 15K. So, this is a value including the tolerance. This is the value not considering the tolerance. Okay, so what is the tolerance of this series connection? It will be 16K minus 15K by 15K into 100, right? I'll write the equation. That is, tolerance is equal to 16, that is a value with tolerance, minus 15 by 16 into, by 15 into 100. Okay, that is, here we are subtracting the value of total resistance with tolerance minus the total resistance without tolerance to get the tolerance percentage. I hope it is clear. That is 1 by 15 into 100, right? So if you solve it, it will be 6.67 percentage is the value of the tolerance percentage. So the correct answer for this question is option D, which is 6.67 percentage. Now let us understand or try to say once again what was being discussed in the question. So there are two resistors connected in series and also their tolerance levels are being given. Okay, so the question is being asked to find the tolerance percentage of the series connection. So we have to find the series total resistance including the tolerance and excluding the tolerance. Then subtract the value and find the percentage. So 16K is the value including the tolerance and 15K is the value excluding the tolerance. Very simply, if you add the two resistors, it is 15K. So the percentage of tolerance is 16 minus 15 by 15K into 100. The value obtained is 6.67 percentage. I hope this question was clear. Okay, so these are the questions which I have included in this video. If you are interested in watching these videos on electronic instrument and measurement and error values or error calculation or transducers, please do mention in the comment section. I'll be doing more videos on this subject. Okay, so if you found this video useful, please do like it and also share this video with all your friends. And if you want more videos, please do subscribe to the channel. Thank you.